and a grinding pen in the tight spots. The cookware is now ready to be prepped for enameling. A machine now blasts the entire piece with steel grits, making the surface texture uniform, so the enamel will adhere evenly. The first coat of enamel is strictly to protect the cast iron and prevent it from rusting. Enamel is a form of glass. However, this enamel is engineered to be flexible because metal cookware naturally expands as it heats and contracts as it cools. After a trip through a dryer, the enamel goes into an oven at 850 degrees Celsius for about 45 minutes. During this firing, the hair-thin enamel coating becomes translucent. The second coat of enamel completely seals the porous surface. It's made of some 20 components, including enamel chips, pieces of clear glass, and pigment powders for color. An automated spray system coats the inside first. Workers wipe the edge to prevent the piece from sticking to the conveyor, then the handle because they'll paint that a different color. They spray the handle manually, then the automated system coats the rest. The iron recipe contains a high level of the mineral silicate, which helps the enamel adhere well. Once again, the cookware goes through the dryer, then into the oven at 850 degrees Celsius for about 45 minutes to vitrify the enamel. Once the cookware cools, it undergoes a final visual inspection, the last of 30 quality control checks throughout the production process. Enameled cast iron cookware lasts generations because it doesn't warp over time and remains food safe for life. Biodiesel is a more eco-friendly diesel fuel that's made from vegetable oil or animal fat. Unlike regular diesel and gasoline, producing biodiesel doesn't require petroleum. Instead, the raw materials are locally available and can be recycled from waste. If your car has a diesel engine, it can run on biodiesel fuel, usually without requiring any modifications. While biodiesel and petroleum diesel are similar in energy efficiency and fuel economy, biodiesel is more eco-friendly. For starters, it can be made from what would otherwise have been waste. For example, from vegetable oil of your local fast food joint. The restaurant simply discards its used fryer oil in a receptacle out back. Every few days, a vacuum truck comes by to collect it. In its current state, the oil contains water and food particles, making it unusable for biodiesel production, so the truck transports it to a filtering plant. There, they pump the oil into a holding tank, then heat it up to draw out the water. Once they drain the water, the oil is ready to enter a multi-stage filtering process. First, the oil goes through a vibrating sieve, which strains out the larger pieces of debris. After this first filtering, the oil is already visibly cleaner. Next, it passes through a second vibrating sieve. This one has a finer mesh, therefore it catches smaller particles of debris. After the second stage, the oil looks clean, but still contains microscopic debris. So it enters the third and final filtering stage, passing through 20 ultrafine filter cloths, which trap any particles larger than 1 micron in size. A micron is about 80 times smaller than the width of a human hair. The captured debris leaves a muddy residue on the filters. That vegetable oil which once deep-fried potatoes is now ready to cook up some diesel fuel. Another source of oil for making biodiesel is beef tallow, oil derived from cow fat. Biodiesel producers typically buy tallow from facilities like this one, which specialize in cleaning cow hides for leather tanneries. Sharp revolving blades shear off the fat from the back of the hide. The fat drops onto a conveyor, which moves it into a steam injection cook tank. The tank heats the fat to a gentle boil, extracting the oil. Everything else leaves the tank and drops into a waste container. The oil moves onward, passing through a 2-stage filtration process. Whether the raw material is vegetable oil or beef tallow, the biodiesel producers refer to this main ingredient as feedstock. When the feedstock arrives at the biodiesel plant, it goes into a holding tank until production time. This demonstration illustrates the production recipe. They take the feedstock and combine it with methanol, a type of wood alcohol, as well as with a catalyst, which triggers a chemical reaction. A processing unit mixes everything thoroughly while applying heat and pressure. The resulting chemical reaction produces a harmless byproduct, glycerin, a common ingredient in soaps and cosmetics. Processing consumes much of the methanol. Then they remove even more, leaving just a tiny percentage of it in the finished biodiesel. To ensure their fuel meets international regulatory standards, the plant's quality control lab tests samples from each production run. In this flammability test, they heat the fuel to 135 degrees Celsius, then apply a flame to see whether the gases ignite. If they do, they have to remove more methanol to make the fuel safe. If they don't ignite, the fuel meets international safety standards. Biodiesel costs more at the pump, but emits significantly less carbon dioxide and monoxide, and 85% fewer cancer-causing agents into the air we breathe. Until the mid-1800s, people folded or laid their clothes flat, or hung them on hooks or pegs. Once it became more common to store clothes in a wardrobe, someone, historians don't know exactly who, invented the clothes hanger, a hanging device shaped like human shoulders. Since the mid-19th century, hundreds of inventors have patented various shaped hangers, many of which are still being produced today. This Czech company makes wooden hangers in several styles. It uses beech, a hard and durable type of wood. The damp logs air dry outdoors for 7 months, then go into a kiln for 3 to 4 weeks. Drying the wood is critical, otherwise the hangers would expand and contract with temperature changes and eventually crack. Workers first use a bandsaw to slice the logs into 6 centimeter thick planks. Then they put each plank through a broaching machine. Inside, a toothed blade planes the wood, rendering the top and bottom surfaces level and smooth. Next stop is a grinding machine, which contains abrasive belts. Workers feed the planks into the machine one at a time. As each plank passes through, the belts above it sand the top silky smooth. When the plank exits the machine, workers flip and refeed it to smooth the other side. An automated saw cuts each plank in half and trims the halves to a specific dimension. The now smaller planks go into another grinding machine, which sands the sides smooth. Now the hanger shaping begins. Workers stack 10 planks, and using a circular saw, cut them to the same length, the ends at a 60-degree angle. They mount 4 planks at a time on a milling machine, and cut a tongue and groove profile on the edges. They'll later connect the hanger parts by fitting the tongues into the grooves. Stacking 6 planks now, they trace a hanger-shaped template on the top surface, then carefully follow the trace line with a jigsaw. Each plank is now roughly shaped into half a hanger, which they call a lamella. This particular hanger is designed for dresses, so they mill a groove in the shoulder of each lamella for garment straps. Then an automated milling machine refines and finalizes the hanger shape, smoothing the roughly cut wood in the process. Next, with strong cabinet maker's glue, they coat the tongues and grooves of 2 lamellas, then fit them together on a press. They let the glue dry for a day, then saw the point off the top. This creates a flat area into which to insert the hanger's hook. There's already a hole for it there, made when they milled the tongue and groove profile. Next, they sand the joint to remove excess glue and smooth out any nicks or tears in the wood. Then they round the angular joint. To seal and protect the wood, they now spray the entire surface with varnish. When it dries, they do a rough sanding, then apply a second coat and let that dry. Many customers want their logo printed on the hangers they order. The printing machine coats a logo-embossed rubber pad with ink. A sponge dabs the pad, then stamps the logo onto the hanger. Finally, the hanger's iron hook. It's either nickel-plated for a silver tone or brass-plated for a gold tone. Workers position the hook, then a press rams it into the wood 1 centimeter deep. The hook has screw-like threads at the base, which grab and lock into the surrounding wood. For certain models, the factory stains or paints the wood prior to varnishing it. After all, many people like their clothes hangers to make a fashion statement too. An erupting volcano led to the invention of stone wool insulation a century and a half ago. It was observed that volcanic lava could be whipped into woolly tufts by prevailing winds. Soon, this was being replicated in factories to produce stone wool for insulation. Shaped into bats, stone wool insulation can be tucked snugly between the studs of a framed wall. It acts as both a thermal and acoustic insulator. Here's the soundproofing proof. In this demonstration, an activated alarm goes into a box lined with stone wool. When the lid is closed, the sound is contained. When it's lifted again, the annoying sound is back. They make stone wool from basalt rock and slag recycled from the steel industry. The process is fueled by coke, which is a form of coal. Basalt rock is solidified lava, formed when rock melts underground and then quickly cools. After the rock has been partially crushed at the quarry, a loader scoops it onto a screen to separate the bigger pieces from the fine particles. The particles will be processed into briquettes, which can be used in the production of stone wool, along with the bigger pieces of rock. The rock and briquettes, along with the steel slag, melt into lava in a furnace. Temperatures reach 1500 degrees Celsius.